Do you know how many buildings collapse every single year? Actually, hold up, let me rephrase the question. Do you know how many buildings collapse every single year that shouldn't have? While rare, structural collapses due to design flaws or poor construction can have devastating consequences. This highlights the importance of strict engineering standards and regular safety inspections to prevent such failures. And while these instances might seem like isolated incidents or just bad luck, they actually point to something much bigger. They point to the critical need for structural engineering. Now, structural engineering isn't exactly the sexiest topic, but it is vital to our survival. These engineers are the unsung heroes to ensure that our cities are not only beautiful and functional, but also safe. They're the ones who figure out how buildings stand, bridges stay upright, and skyscrapers don't topple over in storm. So if you want to design cities, you need to start with the basics. You need to understand the fundamental principles of structural engineering that make all of this possible. If you thought being a city designer was all about aesthetics and urban planning, think again. You can have the most beautiful skyline in the world, but if it's not structurally sound, it's all gonna come crashing down. And no one wants to live in a city that's constantly crumbling around them. You want to design cities, you gotta start at the bottom and work your way up. You gotta understand the nitty-gritty of how buildings stand and how they withstand the test of time. It's not enough to just have a pretty picture in your head. You need to know the science behind it all. Let's start with a simple question. How do buildings stand up? I mean, they're just made of blocks and mortar, right? Well, not exactly. The modern skyscraper is a marvel of engineering and technology, a testament to human ingenuity and the power of physics. These towering giants of steel and glass seem to defy gravity itself, reaching for the sky with an effortless grace. But don't be fooled by their seemingly effortless presence. Skyscrapers are only as stable as their foundations, which are often more complex than you might imagine. Now let's talk about the secret to a skyscraper's stability, its foundation. The foundation of a skyscraper is the structure that supports the entire building. It transfers the weight of the building to the ground below. And trust me when I say that a skyscraper's foundation is no joke. We're talking about supporting thousands, even millions of pounds of weight. This is where structural engineers really earn their keep. They've got to ensure that the foundation is strong enough to withstand the weight of the building as well as any external forces like wind or earthquakes. Now there are different types of foundations depending on the soil conditions and the weight of the building. Some common types include shallow foundations, like a raft foundation that distributes the load over a wide area, and deep foundations, like pile foundations that transfer the load deep into the ground. Structural engineers use their knowledge of soil mechanics and structural analysis to determine the best type of foundation for a particular building. They also have to consider factors like soil erosion, settlement, and the impact of the foundation on the surrounding environment. But wait, there's more. The foundation is just the beginning. Structural engineers also play a crucial role in designing the building's frame. The frame is the skeleton of the building that provides the overall stability and strength. It transfers the loads from the foundation to the rest of the building and distributes them evenly. There are different types of frames including rigid frames, braced frames, and trusses. Each type has its own advantages and disadvantages, and structural engineers must carefully consider the loads and the building's design to determine the best option. Oh, now let's talk about one of the most important aspects of structural engineering: load calculations. Structural engineers are responsible for calculating the loads that a building will experience during its lifetime. These loads can include dead loads, which are the weight of the building itself, and live loads, which are the weight of people or objects that will be inside the building. They also have to consider environmental loads such as wind, earthquakes, and snow. To calculate these loads, structural engineers use specialized software and their own engineering expertise. Once they have the load calculations, they can design the building's structural system to withstand those loads safely. And let's not forget about materials. The materials used to construct a building can have a significant impact on its structural integrity. Structural engineers must have a thorough understanding of the properties of different materials such as steel, concrete, and wood. They also need to stay up to date with the latest advancements in material technology as new materials are developed. For example, high-performance concrete and advanced steel alloys that are stronger and more resistant to corrosion. One of the most important aspects of structural engineering is the design of joints. Joints are the connections between structural members such as beams, columns, and braces. The strength and stability of a structure depends on the integrity of its joints. Structural engineers use their knowledge of mechanics and material science to design joints that can withstand the loads and forces that they will be exposed to. This involves selecting the right type of joint, as well as the right fasteners and other hardware to ensure that the joint is strong and durable. Structural engineers also need to consider the constructability of the structure they are designing. This means that they need to take into account the methods and techniques that will be used to construct the building and ensure that the design is feasible and cost-effective. They work closely with contractors and construction managers to ensure that the building can be constructed safely and efficiently. Now let us take a look at a real-life example of a structural failure and see how it could have been prevented with proper planning and engineering. In 2009, a 5-story parking garage in Minnesota collapsed during construction. This accident resulted in the death of 13 people and several injuries. Now, the primary cause of this collapse was determined to be the failure of the floor system. During construction, the floor system was not adequately supported, leading to a progressive collapse of the structure. Additionally, there were communication issues between the design team and the construction team, which contributed to the accident. This tragedy could have been avoided if proper engineering and construction practices had been followed. Now, imagine you're designing a new high-rise apartment building in a major city. There are several key structural considerations that you'll need to take into account. One of the most important things to consider is the seismic activity in the area. Cities located in seismically active zones need to have structures that can withstand earthquakes. This means incorporating special features into the building's structural system to help it resist the shaking and swaying that occurs during an earthquake. Structural engineers use advanced analysis techniques and design strategies to ensure that the building is stable and safe in the event of an earthquake. Another important consideration is wind loads. High-rise buildings are particularly susceptible to wind load damage, so it's important to design a structure that can withstand high wind loads and prevent it from swaying or vibrating excessively. Structural engineers use sophisticated computer models to simulate the effects of wind on the building, and they incorporate design features such as tuned mass dampers or wind braces to counteract the effects of wind. Now, let's talk about construction. How the building is constructed can have a major impact on its structural integrity. Structural engineers work closely with construction crews to ensure that the building is constructed according to the plans and specifications. They also conduct inspections and tests to verify that the materials and construction methods meet industry standards and building codes. Cities are more than just concrete jungles. They're living, breathing ecosystems that need to be planned and designed with care. Structural engineering is one of the most important aspects of city planning because without a solid foundation and framework, everything else falls apart. By understanding the basics of structural engineering, you'll be able to appreciate the complexity and importance of this field and how it impacts our everyday lives. So whether you want to be a structural engineer yourself or you just want to be better informed about the cities you live in, hopefully this video was a good first step. Remember, the next time you're admiring a skyscraper or a bridge, remember the structural engineers who made it possible. They may not be in the spotlight, but they're the ones who really make our world stand up. And if you enjoyed this video, please don't forget to hit the like button and subscribe to our channel. Your support means everything to us and helps us continue creating awesome content. Also, feel free to drop your thoughts and comments down below and let us know what you think. And if you had any suggestions for future videos, we'd love to hear them. Thanks for watching and we'll catch you in the next one.